Okay, so welcome to Chapter 1. This is for my A Plus Hardware course. This is focusing on the Gene Andrews 6th edition book. This is for the 220-801 exam. Alright, so Chapter 1, it's first looking at computer parts and tools. We're looking at kind of what are the key essentials and what tools are going to be used. So, what's inside the case? Or what do we call the case? Normally, the case, the chassis, the housing, houses very specific parts. It's going to house all of the main internal components like a power supply, a motherboard, processor, the memory and memory module, if there's add-on cards or their hard drives or additional types of items that will be there. Now, if you're not unsure or not understanding what power supplies are, what the motherboard is, that's what the preceding chapters are focusing on. Right now, we're just kind of generally talking about the overview of the computer. Next, there are many types of different computer cases. For example, you could have one that's actually perpendicular to your desk. It actually rises off of the desk. That's more like a tower. It's upright. You could have a desktop that could lay more parallel with your desk. That's more laying flat on your desk. You could have a laptop or a tablet or a mobile type device. Those are better defined later on in other exams, but I mean, a laptop, whether it be any component that falls underneath the laptop category. Lastly, we could have all-in-one. An all-in-one is literally every component you need in a very small, thin case, but it's not very mobile because they're a little bit bulkier. So the next thing is we have to be able to look at common components and see and understand what they are. For example, the top one is a VGA, a DB15. First of all, if you count how many holes there are 15 holes. It looks like a giant D, hence the DB. S-Video, which is not so common anymore, but it's still occasionally tested on. Underneath that, we have one version of DVI, and you'll notice it's similar to the VGA. It's a D-like cable, but this is a digital interface, and it is white. The cables for VGA, you'll always will notice that the tips are blue. The DVI cables, more often than not, are going to be white tipped because, again, they want you to see matching components. VGA is analog, DVI is digital, so there is a slow shift to move away from analog technology. And again, I want to talk about that in greater detail in Chapter 6. Next is HDMI. That will do a digital video signal, but it also does audio as well. That's slowly being replaced by DisplayPort, but it kind of really depends on what you're plugging into. Like HDMI is very common for TVs, where DisplayPort is very common for computers. Underneath that is our Thunderbolts. That is very similar to DisplayPort. Like if you look at the port itself, they look identical. Thunderbolt is typically common for Apple-based devices. Next is a network jack or network port, the female end. So it actually is, you can sometimes call it an RJ45 port, but it's the female portion. It is where you plug in for network connectivity. Next, we have our general audio. Most often you'll see it pink, green, blue. We have a digital audio or SPDIF. Again, it's an optical audio. Underneath that, we have USBs. You'll notice that they're black, and that's kind of important. These guys are black. If they were blue, they would be USB 3, but because they're not blue, they are not USB 3. Next is FireWire. Notice the shape. That's very rarely tested on, but sometimes. eSATA or external SATA, very similar to USB, but they're used for powering storage devices. Almost done. We have our PS2 ports. We have one purple for keyboard, one green for mouse. we have a DB9 or a MEL 9. You'll notice there are 9 pins. They're not female, they're actually male, they actually protrude. This is used for configuring type of devices. It's also called a COM port, it's also called a serial port, also called a 232 port. Alright, so some additional ports that are not very common are going to be our parallel port, DB25, that's for old printers, and modem ports, which is an RJ11. Those are way old and normally not tested on. Alright, so let's look at the inside of a computer. So at the very top, this guy right here is our power supply. So power supply. Here we have our memory modules. Here we have our processor. Here we have our back I/O. That's what the ports that we just covered. Here we have our additional add-on cards. So the blue one, you're going to notice there's a little notch towards the back of the case. If there's a notch towards the back of the case, it's PCI Express. If the notch is away from the back, it's just regular PCI. These thin red cables are going to be our SATA cables. These yellow, black, and red cables are power cables. Up at the very top, it looks like there's an optical drive plugged in, like a CD or a DVD player. Down at the bottom, you'll notice there are 2 hard drives plugged in. Here we have the front part of the case, and as a whole, it's the case. So, a motherboard, that's the central board that everything gets plugged into. The processor is more like the brains of the computer, and the processor does generate heat just like a human brain does, and so normally we put a heatsink and fan on top of it. That way it's actively cooled, meaning there's air being pushed around it. Here we go. So the processor sits underneath the processor fan. The processor fan gets plugged into the motherboard. But the big thing here is, notice the fan. The fan provides air movement. It's actively cooled. I did point out the back of the case where the things were plugged in. We've already covered all of those ports. Oh, look, here we have our blue USB. So that's USB 3. It's important to be able to look at this and know what the different ports are. Never underestimate the importance of being able to look at it and being able to identify fairly quickly exactly what it is. Here's our memory modules next to the processor. We have a black, blue, black, blue. Why are they black and blue? Honestly, your best bet is to consult the manual to verify. Sometimes we can discuss that they might be dual channel. We're going to talk about that in a later chapter, but normally, just by looking at the color, we do not know. We need to double check the manual to verify. RAM acts as, or memory acts as temporary storage. Essentially, if we're talking about like a desk, RAM is our workspace, like our desktop, the room that we have to work with. If we need more workspace, we get more RAM. Our desk gets bigger. If we want to store things, we have a file cabinet underneath the desk. That's our long-term storage. That's our hard drive. Other forms of storage could be a hard drive or an optical drive. Here we have a mechanical hard drive. Notice its size. We have a more common SSD now, or solid state device. And then we have a optical, whether it be CD or DVD. We already talked about a power supply. Our power supplies will have a switch that switches between either 110 to 120 volt through 220 or 240. Their ranges, so it's not always 115, 220, it may be 120 and 240, but I mean, it's similar in range. It should be around 115, around 220. The reason this is important is because not only do power supplies accept 115, other countries use 220 or 240. So we have to have a way to switch so that our power supplies are more universal. Alright, next we have to talk about the case itself and the motherboard. So there are form factors or case styles that dictate where the placement of holes are so that everything works together. Essentially, we're talking about standards for our case and motherboard. The two big ones are ATX or a variation of ATX, like a mini ATX. Again, ATX dictates where the holes in the motherboard are and where the receiving holes on the case is. That way, our motherboard can be screwed into our case without a problem. All right, it's important to note here, our motherboard gets screwed into case stands. The case stands get screwed into the case. You never screw the motherboard directly into the case without the case stands, because the bottom of the motherboard is metal, so you don't want to cram that onto a metal case. All right, so what does ATX stand for? It's Advanced Technology Extended. It was originally developed by Intel in '95. There have been other variations of ATX like BTX, but they're not very common anymore. The common ATX power connectors are listed on our next slide. We have to talk about power because, again, this is the standard for our case and motherboard. So the big ones are a 20 or 24 pin main connector. This is a main power cable for our motherboard. It's called the P1 cable. It is very commonly looking like that. That's our main power cable. We have a 4-pin and 8-pin auxiliary cable that's close to the power supply. Very commonly, we can have two 4-pins that combine to make an 8-pin, or we could have a 4-pin and an 8-pin, just kind of depends. Lastly, we could have a dedicated PCIe connector because everything connects to the motherboard. All of this power is powering the motherboard, but let's say you have a high-end video card. That video card may draw so much power that the motherboard may not be able to support it. So that's why we have these 8-pin or 6-pin PCI connectors, and you'll notice they will say PCI on them. It will probably be a 6-pin with a 2-pin add-in to make that total 8-pin, but this 8-pin is different from a motherboard 8-pin, and you can always tell because these are differently shaped. So if you try to take a PCI 8-pin and it doesn't fit into the motherboard, you know something is wrong. Stop. Okay, moving on, we have other forms of ATX like micro ATX and mini ATX and things like that. Again, the big thing here is with ATX, the goal here is to reduce the total cost of a system. We could do that several different ways. We could do smaller cases, we could do smaller add-ons, we could do lots of small things so that we can make them cheaper. Here is a micro ATX. So it's not as large as a regular ATX. It's more of a mini, but this is cheaper to make. But you're limited to what you can add on. You can only add on one PCI Express. Again, that notches towards the back of the case. You can only have two PCI add-ons. You can only have two memory modules. So this may work for some people and not for others, just kind of depending on their needs. All right, so hard drives. Hard drives come in two major flavors, SATA and parallel ATA or PATA. So SATA is that red cable we looked at earlier, where parallel ATA is going to be more like a flat ribbon cable. Those are older, and so you shouldn't really see any more PATAs out there. Everything is moved more towards serial ATA. Occasionally, you still may see a floppy. Floppies are also ribbon cable, so that PATA will use a flat ribbon cable like this, and it'll get plugged into the motherboards where there are a male connector. There will be a notch, so you cannot misplug the cable. But again, these aren't as common anymore, so it's more of a, hey, you know, this may happen, you may see this, but you really shouldn't be seeing them. Moving on, let's go to protecting ourselves from electrical static discharge or electrical dangers. So electrical static discharge, I'm going to call ESD from now on. The big thing here is we have to understand how to prevent electrical discharge so that first of all we don't get shocked, and second we don't damage individual components. Okay, so since we're talking about electricity, we have to talk about a few key terms. First of all, AC versus DC. AC is alternating current. It oscillates between a positive and negative voltage. House current in the US oscillates 60 times in 1 second. It normally runs at 110 to 120 volts. While DC current travels in one direction, this type of the current is used by most electrical devices. So like laptops and phones use DC, and so we actually have to have some type of converter to convert AC to DC. So we have a rectifier. That's the device that converts it from AC to DC, and we have an inverter that converts it from DC to AC. Lastly, we have to understand what a transformer is. A transformer is a device that changes the ratio of voltage to current. Example, our power in could be a high voltage but less current. The transformer may change it so it's more current and less voltage. So it will actually step down the voltage to give us additional current or flow. So AC travels on a hot line from a power station, and then AC returns on a neutral line or a ground line. When AC flows through an unattended or unintended path, meaning one with the less resistance, a short can occur. Essentially, a short is just we want power to go one direction and it took a path we weren't expecting. A short can also be a sudden increase in flow that can create a sudden increase in temperature. Because again, the movement of electrons can actually cause heat. The neutral line is grounded to prevent uncontrolled electricity in a short. Grounding is the line is connected directly to the earth so that the electricity can flow back to earth. Grounding literally is a cable that goes back to earth or back to the ground. That way electricity can flow back to the ground. If we're looking at an outlet, normally the hot is going to be the smaller plug, and the other two will be our neutral and or ground. You may not have the third plug. In that case, our neutral is also the ground. Okay, so that's our typical power plug. So potential dangers when we're dealing with electricity could be things like power cords that are frayed or damaged, power cords in liquid, physical damage based off of a device that were dropped on it, electrical burning odor, power supply fans making a whiny noise. The unit could be overheating, could be smoke, could be lots of different things when we're dealing with electricity. How do we protect ourselves from electrical shocks and burns? Normally, if we're dealing with a motherboard or processor, we're going to be grounding ourselves, and we're going to do that through a grounding bracelet or a grounding mat or by holding metal on the case. When we're working with certain components in the computer, we should be able to have immediate replacement parts. For example, if you think a power supply is having issues, you don't work on it. You just replace it. That's called a filled replaceable unit or FRU. So, now let's talk about fires. So first of all, never use water to put out a fire. Water is a conductor. See gotta be careful with this one. It depends on the type of fire. Not all fires are the same. So we're going to look at three common classes, class A, B, and C. A class A, you can use water to put out a fire caused by wood, paper, or other combustibles. Class B can be put out fires caused by liquids such as gasoline, kerosene, or oil. So you would never want to put water on gas, kerosene, or oil because the water would spread the gas, kerosene, and oil. So That's why there's separate classes of extinguishers. Class C is non-conductive chemical to put out a fire caused by electricity. Because again, we don't want to have water, because a water is a conductive or a conductor, so that would actually spread the electricity. So we got to be careful with what type of fire we're dealing with and what type of fire extinguisher we're going to have. Now, a fire extinguisher can be rated for several things. Here we have a Class C fire extinguisher. All right, moving on to ESD. Electrostatic discharge is when two objects that with dissimilar electrical charges touch, it'll be a discharge. You rub your feet on the carpet, you touch someone. You have a more charged than they do, so when you touch them, you discharge your electricity into them. That causes static electricity. Again, your feet rubbing on carpet with socks, and then touching someone, that shock is that ESD. So to protect against ESD, we always ground ourselves. Again, that's with a bracelet or a strap. It could be through anti-static shield bags if we're dealing with major components. It could also be with gloves that are special for ESD. So normally the electric static wrist strap is going to be the most common one. Common rules. Basically, when passing circuit boards, we ground ourselves and we touch the other person before we pass the board, or we put it on the table and we let them move it. Again, as long as we have the same electrical charge, we shouldn't have a problem. We leave components inside anti-static bags until we're ready to use them. We work on hardwood floors, not carpet, because again, carpet helps us build static electricity. Normally, we don't do work on a cold or dry atmosphere. We remove package tape and styrofoam from the work area. All of these materials make ESD, and we keep components away from hair and clothes because hair and clothes can cause static electricity. All right, one of the last major things we're going to talk about is tools used by a technician. First of all, grounding wrist strap or grounding gloves, screwdrivers, tweezers, the appropriate software, maybe a toolbox. We could also deal with a power supply tester here in the middle, a postcard, those are less common, a multimeter, electrical unit to test an outlet, flashlights, compressed air. Here is our wrist strap. We also have anti-static gloves and screwdrivers and some other items. So let's look at that postcard. A postcard is a card that used to be very common, not so much anymore, but it would actually give you a readout for the power on self-test to give you more specific output of what was happening during post. That way, if your PC didn't post, you could understand exactly why. Your post-diagnostic card, it actually had its own BIOS, and again, it was to help manage and understand BIOS a lot better. Not so much used anymore, but at one point they were very common. We have a power supply tester. Here's just one form of power supply tester. This will test the appropriate power for our P1. Here we have it testing our P1. It is testing for 5 volts, 12 volts, and 3.3 volts, or close to that proximity. We're looking at a multimeter. Again, that's going to be used to test electrical characteristics. A loopback plug if we want to check a physical network adapter. The appropriate cleaning solutions, and with an MSDS, material safety data sheet, explaining how to use them and how to properly handle them, because you may end up with chemicals you're not sure how to use and how to store and or how to clean up if an issue does arise. So you have to have an MSDS so that you understand how to use all of them and how to clean them and how to store them, all of that fun stuff. Lastly is going to be managing cables so that we're not making a mess, we're not making an unsafe work area By managing cables, we do have a safer environment. We don't have tripping concerns anymore. All right, the last thing, which is pretty straightforward, heavy lifting objects. Lift with your knees, not your back. If it's too heavy, get a partner, get a cart. It's teamwork. Don't hurt yourself. I've never really had any questions dealing with lifting heavy objects, but it's something that you should know. And last, a summary. So, if you guys have any questions, please let me know. You guys have a great day.